Now, we're in RGES Algebra 1, Lesson 29B, and this is Part 2. We are illustrating several kinds of word problems so that you can do your homework on sections 11.9 and 11.10. So we're in 11.10 right now, and we are on example 2, page 508. This is a work problem. The last one was a rate problem. A work problem, the big thing to remember is that the entire job is going to equal the total. And so we're going to talk about portions of a job and the total. So the job or the work is 1. Okay. The rate will be 1 over the number of hours it takes to do it individually. Okay. So if, in other words, if the fill pipe, it says the fill pipe can fill an empty swimming pool in 5 hours, so it does 1/5 of the whole job per hour. So that would be the rate of the fill pipe. The rate of the hose, we don't know, because the next part says with the fill pipe and the hose together, it takes only 3 hours. So we don't know how, and then it says how long will it take to fill the pool with just the hose. So 1 over H per hour is the rate of the hose by itself. See how that works? Now, altogether, 1/5 plus 1 over H is the whole job in how many hours? So this is the rate together, okay, times the number of hours, in this case 3, is going to equal the job. Okay, the rate times the hours equals how long it takes to do the job. Okay, or in that you complete the entire job. That's why this is a 1. It means the whole job rather than a portion of the job. All right, so now if we distributed that out, we get 3/5 plus 3H equals 1. Our common denominator will be 5H, H for hose. Okay. The 5 will cancel, we'll get 3 times H for the first term. The H will cancel, we'll get 15 for the second term, and on the right-hand side, no cancellation, 5H. If we plug that over there, that's an H, believe it or not. H. All right, subtracting, we get 2H equals 15. Dividing, we'll get H equals 7.5, or 7.5. What is that? 7.5 is how long it's going to take. 7.5 hours is how long it would take for the hose to fill it alone. This H doesn't stand for hours, it stands for the hose. 7.5 hours for the hose. By itself. Okay. So always with work problems, you want to think in terms of rates, which is the amount per hour for each worker or each construct. In this case, how long for the pipe to fill it, how long for the hose to fill it. Okay, it's a fraction, okay, per hour. Okay, so that's your kind of pattern there. Okay, so in other words, if I instead had worker number 1 does the job alone in 7 hours, and worker number 2 does the job alone in 5 hours. Okay, my 2 rates would be, he does 1/7 of the job every hour. That would be rate for worker number 1. He does 1/5 of the job every hour. if he's doing it alone. How long would it take him to do it together? Okay. And then you're talking about the whole thing adds up to the whole job. Okay, something like that. Okay, so this is the whole job. And these are the parts that each person contributes. Okay, so there's just kind of the illustration of the whole idea. Now the next one, example 3, it says an integer quotient problem. When a certain large positive number is divided by a smaller positive integer, a large positive integer is divided by a smaller positive integer, the integer part of the quotient is 2 and the remainder is 9. The sum of the integers is 48. Find the two integers. All right, so for this one, what we're going to do is we're talking about the large integer, the small integer. A large positive integer is divided by a small. Okay. So we would say x over y. That's the division. The integer part of the quotient is 2, and the remainder is 9. Well, let's think about that for a second. If this were my smaller one and this were my larger one, and I would divide, I could get 2, remainder 1. Now, how would I express that? I would express it as 2 and 1/3, or 2 plus 1/3. So down here, this will equal, the integer part of the quotient is 2, and the remainder is going to be 9 over what? The smaller one, the one I divide by. Make sense? So I'm taking that expression and writing it with the information I have here. So now the second equation, so that's one idea. The second equation is the sum of the integers. That would be x plus y equals 48. Find the two integers. Well, okay, so here's my expression number 1, and here's my expression number 2. How would I find those? Well, I can only solve for 1, so I'm thinking I'm going to go ahead and solve this for x, and then substitute it up here. Okay? And then solve for the y's. So x is going to be 48 minus y. We're going to plug that back in, and we're going to get 48 minus y over y equals 2 plus 9 over y. My common denominator will be y. We'll cancel it out on the left side, and we'll get 48 minus y. We'll multiply it through in the second term. We'll get 2y. We'll cancel it out in the third term, and we'll get plus 9. Now go ahead and solve that, and you're going to end up with y equals 13. That's the smaller of the two. Right? So how would I then solve it for the x? I'd go ahead and plug that 13 right back in here, and x plus 13 equals 48, so x will have to equal 35. So my two numbers, my two integers are going to be 35 and 13. Let's check it out. It says if I have a quotient, if I say 35 divided by 13, I should get what? 2, which is 26, remainder 9. And that's what I have here. So that checks out. And do the two add up to give me 48? Yes. So it checks out. All right. So again, you can look at that again if you need to. Let me do you one more example, example 4. Example 4 calls it a Soup can probability problem. A flood washes all the labels off the soup cans in a grocery store. Inventory records how Inventory records show that there were 300 cans of tomato soup and 500 cans of beef barley before the flood. Okay, so tomato and beef barley. Tomato has 500, beef barley had 300. The question, if a can is picked at random, what is the probability that it's tomato? Well, we only have 2 cans, right? Okay. And altogether, we only have 2 possibilities. Let me read that again. What's the probability that it's beef barley? What's the probability of that it's tomato? Okay, so the probability that I would draw a tomato would be 300 out of how many cans there are? 800, or 3/8. So the probability that I would draw a beef barley would be 500 out of how many cans in all? Or 800, so that would be 5/8. So that would be A, probability of each. Okay. B, if 100 cans are picked at random, how many cans of beef barley? Well, what is my probability of beef barley? 5/8. Okay. And if I pick 100 cans, okay, I tend to show this a little different, think about it a little different. So there's my probability of beef over the total. If the total number of cans I pick are 100, what would be the probability of beef? I would tend to just set it up as a proportion, cross multiply, divide, and x equals 62 1/2. So the probability that I would pick, of course you can't have a half, but I'd either pick, if I'm picking 100 times, either 62 or 63 times, I would pick barley, beef barley, rather than tomato. How many cans total would you have to take in order for the expected number of cans of tomato soup to be 60? Now again, I like to think about this in terms of the ratio. A ratio problem mathematically. In other words, a proportion like this. Okay. So if I had a proportion, so now how many cans total would you have to take in order to get 60 tomatoes? Okay. Now just as above, okay, if I had kind of thinking about, well, I don't know, maybe not thinking like that. Okay, if I have, this is my ratio, my proportion, it's really my ratio, times the number of cans I pick, would give me the number of times I'd have of a certain one. The ratio of the tomato here would be the number of tomato here. Okay. So I'm just going to say that you don't know this, but I know the total number. Let's see, how many cans total. This is what I know, so that's where I'll put my value, which is I'm sorry, that's not what I know. Let's read that over again. How many cans total? That's the number of picks. This is the total. Okay, number of cans. Would you have to take? So that's what I'm solving for. In order to the expected number of the number of tomato cans to be 60. That's what I'm trying to do. In trying to make it look simple to you, I wasn't very clear. Sorry. So what would we do here? We'd multiply by the inverse, right, or the reciprocal, and x equals 160 canes. Okay, so sometimes explain it a little different than they do. Now, your homework then, I'll review before. Your homework is going to be 11.9, 1 through 5 all. We'll go over the answers later. And 11.10, 1 through 5 all. Those will take quite a bit of thinking through. Also begin to review Chapter 11. Now, because we'll have a test, that's all we're going to cover in Chapter 11. That is the end of the unit. So we'll just be doing some review, and you'll have your test when you get back. When you get back from what? We're going to have Easter break. Okay, so we have our Easter vacation next week, which means that there will be no tapes next week. We'll start with lesson 30 the week you get back after the 12th, right? So the 12th is Easter. So Easter vacation, no tapes next week. So you have a blessed time. Catch up. Use the time to catch up if you need to, and that'll be wonderful, because after that, after we get back, we only have 5 more weeks of school. And of course, you want to be able to get credit for this spring semester, this spring quarter, and so you need to really keep up. No tapes next week. However, next week, as you're doing this, or if you do it the rest of this week, and you really, well, I would say if you don't understand, just give me a heads up, but I will give out the tape. I will cover it on the next tape we're together, but give me a heads up on problems that you're having trouble with, all right, by texting it to me. Okay, excellent. Have a blessed week.